Hello and welcome. This is Art Fuel, and today I'll be walking through an NSXT 2.4 manual installation. We're going to be using the PKS-Ninja-Lab guide for this installation, so you can follow along with the lab guide if you'd like. The website is github.com/cnatech/PKS-Ninja, and once you get to the home page, you can click on Lab Guides and then look through the list here for NSXT manual install. Now, one thing you always want to do here, notice here this box that says branch. I'm on the master branch, and for PKS 1.4, we're going to make sure that we select the PKS 1.4, which is associated here with the NSXT 2.4 manual installation in this GitHub repository. Now, PKS 1.4 is compatible with either NSXT 2.3 or 2.4, but we're going to use 2.4 today. Now, to access the lab environment, if you have access to a lab environment, if you're a VMware employee, you have access. If you're outside of VMware, you may have already been provisioned access through VMware Learning Platform or have a different way of accessing OneCloud. You can see getting access to a PKS-Ninja-Lab environment here for more details on accessing a lab environment. And if you don't have access to lab environment, definitely still feel free to follow along the video, look through the lab materials. As you can see, there's screenshots pretty much for every mouse click, and so hopefully this will be useful for you still. So first things first, let's talk about how do we get access to the lab environment real quick. And so if you're a VMware employee, if you already know how to access and use OneCloud, you can hopefully find these templates in our lab template in the your OneCloud environment, or you can open an issue ticket on the GitHub site here under issues if it's not available in the partition that you're trying to access. For most VMware employees, the easiest way to access is through Quick Demo. So if you go into Workspace 1 and you start searching for Quick Demo, and you can see here, Quick Demo shows up, and I could open that there, and I already have it open on this other tab here. So once you log into Quick Demo, you'll be able to come and see a list of different templates. The one that we're going to be using today is this PKS Ninja V12 baseline. This is a template that is has vCenter pre-installed, but it does not have NSXT or PKS installed yet. It's prepped so that way you can load this up and begin the installation with this lab guide and follow along exactly. So you can go ahead and enroll and open that. If you may be accessing through the hosted eval, in which case it looks almost exactly the same. You just go to the VMware Learning Platform.com hosted eval link, sign in with your username and password, and you'll be able to also see the same set of templates here. And we should have, actually, I'll make sure I add that. It doesn't look like the baseline is here, but I'll add that here in a few minutes. Okay, so now we can go ahead and jump into our lab environment. I already have an RDP session open here. And if you are connecting through your browser, through VMware Learning Platform, a Quick Demo, or hosted eval tenants, and if you're a VMware employee, you can RDP in. So you'll have to first access the environment through your browser. And once you get inside the environment, you can go open a web browser and type in myip.oc.vmware.com, and you'll get an IP address that you can RDP to if you're a VMware employee. And if you're not, you may be able to try some third-party tools like LogMeIn or something like that. It may work in this if you want RDP type of access. Otherwise, you can access and the entire environment and complete all exercises through the in-browser RDP session. So let me. Now, I'm going to go ahead and I'm going to be following through these instructions as I go along. I'm in a multi-monitor setup, so I'm going to pull those instructions to the other monitor, but I'll let you know where I'm at with the instructions as I go along. So as you can see here, my base lab environment, I've opened up my vSphere web client, and I can see here that I have a vSphere environment that it has essentially nothing in it. It has this CLI VM, which is just a Ubuntu jump box we can use, and then there's a vRealize login site server, but I don't have any NSXT or PKS running yet. So now to go ahead and get started with the first step. First thing we're going to do is we're going to deploy NSXT manager. So we'll do that with as an OVF template. Deploy OVF template. Click on local file. And most of the files that you need for doing the installation should be here in the E drive in the downloads directory. And we're going to look for our NSX unified appliance. And you can feel free to use the version that's saved here, or if you have access, you can load a more recent version. Anything in the 2.4.1 train, it should work with these same instructions. Okay. And we'll go ahead and click next. And let's see, I'm going to call this, what am I going to call this? NSX Manager 01A, and that the purpose, I'm just naming this in accordance with our standard lab conventions, but you can name it whatever you'd like there. And this is the name that appears in vCenter when the virtual machine shows up here in the hosts and clusters view. And we're going to put this in our management cluster. And I do, just so you're aware, if there are any times where the system sits here and thinks for a minute, I do try to pause the video so you don't have to sit through wait times when things like that occur. So when we go in here, we're going to go ahead, and I'm going to go ahead and do the small configuration. This is a lab environment that's pretty oversubscribed, so we're going to try to keep things as small as possible. And I do everything thin provisioned in this lab environment. If you have a different lab environment or a physical environment with lots of capacity, thick provision is the highest performing, but thin provision is best for limited environments. Now notice when I opened this window, the default selection I think was the first. I switched to thin provision, and when I switched over to the appropriate data store here, it actually switched it back to thick provision. So keep an eye out for that. So I'm going to reselect thin provision here. And in this environment, I'm going to use this iSCSI 02-compo1 array. You can see I have a lot more capacity on this drive. For the network, we'll go ahead and leave it here in this environment on VM region A01 VDS management. Actually, yeah, we'll leave it in the VM management network here. And we'll go ahead and click next. And then I need to configure values here. Now, if you're looking at the lab guide here, you can see I have all the values that I use in the standard lab environment here. So feel free to use these values for your lab environment. If you're going to configure anything in production, don't use these values, right? Make sure that whatever values you do use are appropriate for the lab environment you're using. So if you're using one of the Ninja-Lab templates, use these exact values. So I'm going to just do a little copy and paste here, get these in. And we'll leave the default usernames there. And for our networking, this one's going to be NSX MGR-01A in our lab environment. And make sure that in our lab environment here, we already have our DNS pre-configured for this naming convention. So make sure if you're in a different environment, you set up DNS accordingly. And we'll leave this NSX Manager, NSX Controller role here. And our gateway one and net mask. And our DNS for our lab environment is 110.10, and we have corp.local in our lab environment as the domain search list. NTP, if it takes it, I like to use ntp.corp.local. I know certain things may not like a AFQD in here, so it is also 192.168.100.1 if you'd prefer to use the IP address. I do enable, this is a lab environment, so I have no qualms about enabling SSH and root SSH logins, but again, for production, those are things that you want to have a lot of caution around. And then we click finish, and that's the end of the getting NSXT manager deployed. That's our first step. I'm going to pause here while that deploys, and you can monitor the progress of the deployment in your recent tasks. Okay, we're back now. You can see my NSX Manager OVA has completed deploying, and I will not start it yet. This is something we do in our lab environment for pretty much any OVF that we're going to deploy. We want to go in before we start it, click Edit Settings, and we're going to want to make sure to expand our memory and check to see if there's a reservation. And actually, in this case, there is no reservation, so we didn't have to change anything. We could have gone ahead and started it. In some cases, you'll see that this reserve guest memory is locked. And in lab environments, in production environments, that's a great practice. Make sure you have enough memory for your critical components. In lab environments, sometimes we generally uncheck these when we're dealing with very resource-constrained environments, as otherwise it'll make sure that the entire amount of memory is available on the SXI host, or it won't place it. And again, when you're in a very space-constrained lab environment and you're not as concerned with performance, you can uncheck that and get some additional capacity, essentially, in your lab environment. So now, once we've verified that that is the case, we can go ahead, and I'm on step 1.11 right now. We're actually moving into 1.12, and we're going to right-click on our NSX Manager and press Power On. And I'm going to give that a few minutes, probably give it 5 to 10 minutes to fully boot. And I will resume this video in just a minute to once this is booted up. Okay, I'm back, and as you can see, our NSXT manager has already booted up. Before I get that, little housekeeping information that I forgot to cover before. The lab guide that we're working from here on the PKS-Ninja GitHub site is specific to our lab template and has variables in here that our environment is kind of pre-configured to work with. And so if you are working with your own lab guide, if you're working with the PKS-Ninja lab environment, you will want to follow the exact variables step by step, click by click, copy paste type of information as instructed here. If you're working with a different environment, you can feel free to use this as a reference. But please see the complete documentation for if you are installing NSXT for PKS. Please see the Enterprise PKS documentation at docs.vmware.com, and then VMware Enterprise PKS index.html. And in here you see some NSXT installation instructions that are specific to set it up for PKS. Or otherwise, you can go to the NSXT data center documentation for your preferred reference, which is at this URL here. Okay, now let's get back to, and we are, let's see, where are we in our lab guide? On our lab guide, I think we're like step 1 dot. Just finished finishing step 1.12. We just log in here, and so admin, enter the password, and then we'll enter step 2 here for 2.1 in the lab guide. So go ahead and make sure we understand and accept the EULA here. And it doesn't matter whether you join this or not. Since I'm in a lab environment, I won't. One thing I'll point out is for NSXT 2.4.1, they are highlighting some of the cool new wizards that they have here, and we will use those. But it's one thing that's important to keep in mind is you don't immediately just start clicking here. This splash screen is really intended to show they have new wizards, but you do need to follow them according to the documentation, and don't just start clicking or it will lead you down an incorrect direction. So just follow along with us here, and we'll take advantage of the new wizards, but we will make sure we follow them in the appropriate order. So the first thing we do is we're going to go to System and Fabric, and then Compute Managers. And we're going to add a connection to our vCenter environment. So we'll call it, in our lab environment, this is VCSA-01A. And the full FQDN is vcsa.corp.local. It's a vCenter. I'll use our standard lab and the lab environment passwords. If you're in one of the PKS-Ninja-Lab templates, there's also a README file in the desktop, and the username and passwords are included in the lab guide on GitHub. Oops, and we're going to do administrator at corp.local. And our standard VMware 1bang password, and click add. And we'll go ahead and add this thumbprint here. Okay, and now we can see it is still connecting, so we can give that a minute to connect. And I'll pause the video while that's... Okay, that took less than a minute to do, and now we're going to prepare some assets. Now, one of the things to keep in mind that's with NSXT 2.4.1 is that NSXT 2.4 introduces a new API, but it doesn't yet remove support for the old API. The new API is brand new, and it barely came out, and so most of the products that have integrations with NSXT have not been updated for the new API yet. And so you've got kind of this dual personality here, where these networking security inventory tools tabs here on the left of system, these primarily interface with the new API. And if you're working with an integration in your NSXT environment, you want to focus more on the system and the advanced networking security tab. Basically, the general rule of thumb is if you can configure it through the advanced networking and security tab, do so. Because in some cases, like I can go to the networking tab and say configure a tier 0 router, and when I do it through this networking tab, it's going to make, there's some slight differences with it implements it through the new API, and that can cause problems with integrations if you're using a integration, an NSXT integration such as PKS 1.4, which is still integrated with the older API at this point in time. And okay, so we added that. Now we're going to go to our advanced networking and security, and what we're going to do is now we're going to add an IP pool. And so within NSXT, we do create tunnels in between our ESX hosts that participate in our NSXT domain. And so we need a set of IP, and when we create tunnels, our ESXi hosts get an additional a NIC that is available for for that purpose. And so we need to create a pool of IP addresses, and so and what that does is when we prepare a host to participate in the NSXT domain, those hosts each need to prepare their environment and grab an IP address, and so they can create an interface for the tunnel endpoints. And so we're going to go to inventory, let's see, inventory, groups, and we're going to click on IP pools here, and I'm going to go ahead and click add an IP pool, and we'll call this one our TEP. That stands for tunnel IP, or tunnel endpoint, TEP IP pool. And you can name it whatever you want. This is just the standard for our lab environment. And we'll go ahead and add an IP range here of 192.168. Oops. .130.51 through 192.168.130.16. 75. And this is, we only have 6 ESX hosts in the total environment, so that's more than enough. And I like to tab out of that to make sure that or click out of it to make sure it saves appropriately. And our gateway is going to be 192.168.130.1. And the CIDR is 192.168.130.0/24. DNS server is 192.168.110.192.168.110.10, and the DNS suffix is corp.local. And before you click add, make sure you click out of that and see all the boxes have exited, so we know it is fully added. And then we can go ahead and click add. Now we're going to go ahead and start to use one of the new wizards that helps with installation and configuration. So go to System, and if you're following along in the GitHub lab guide, we're on step 3.3 right now. So we're going to go System, we're going to click Get Started, and set up transport nodes. We'll pick a type NSX Edge VMs. We will need a NSX Edge VM here. And go ahead and click Next. As you can see, we don't have any NSX Edge VMs deployed at this time, so we'll go ahead and click Add New Edge. And we're on step 3.5, so just to show you on this lab guide here, you can see we have all the information needed to configure the edge in accordance with the lab environment. And so I'll go ahead and enter those values. Oops, sorry. Edge 1. A little lag in my keyboard here. There we go. And for our edge, we're going to go ahead and click the large form factor. We'll make some adjustments to fit this into our smaller lab environment here. But the large is important for PKS. Now, if you are deploying PKS in a lab, we'll typically deploy the large, as it says here. At minimum, you generally want to deploy a medium. And the reason why is when you do deploy PKS later, when PKS deploys a Kubernetes cluster, it will, if you're using the NSXT integration, it's going to deploy the load balancer. And this is also true of other Kubernetes services. If you're deploying any Kubernetes with NSXT integration, you do have to be cognizant of how many load balancers are supported for PKS clusters. Medium can only support one. Large supports a much larger number. I forget the exact number, but we're going to go with large, so we have the flexibility in our lab environment if we do want to deploy more than one cluster. Okay, and I'll just copy and paste the password in here that we use. And we use, if you've noticed, a lot of times in the lab we just use the VMware 1 bang password. For NSXT 2.4 here we use VMware 1 bang, and we doubled it up because there is a longer password requirement in 2.4 than there was in 2.3. So we'll go ahead and pick our compute manager, our vCenter environment. We're going to put this on our management cluster. I'm not going to put a resource pool or specify a host. And we'll pick our region AO1, iSCSI 02, Compo 1 data store. And for our ports here, we're going to go ahead and we'll click management is on, let's see, where's management? On the VM management network here, we'll create a static IP address, .91. And we will put the /24 in there for the CIDR notation. And then we'll do .110.1 for our gateway. And then we do, for our ETH0 here, we have this set to be our uplink. For ETH1, this should be our transport. This is where our TEP interface is. The interface should be using that interface. And then finally we'll use the VM management for ETH2 and go ahead and click finish. Now this is going to take a couple minutes to deploy, so I'm going to go ahead and pause the video while this is deploying. And once you can monitor the deployment status here and after a few minutes, this actually won't update, because what's going to happen, we're going to jump into our vSphere, and we deployed the large NSX Edge VM. And so once this finishes deploying, we're going to see an error in our vCenter here if we're looking in our recent tasks, because of the size of the large VM is actually larger than what we have our ESX hosts configured to be able to support in our very space-constrained lab environment here. This is not a problem for our lab environment, because what we can do is we can go in here once this is finished deploying and edit the settings and actually lower the RAM requirement, or lower the RAM that this actually utilizes, that will allow us to deploy it in the lab environment. And it's a little trick. Your PKS environment will still see this as a large NSX Edge and still allow us to deploy more than one cluster. Again, you'll never want to do that in a production environment. I don't know exactly how far you could push that, right? But for a lab environment, if you're very space constrained, this is something that does work to help accommodate a smaller lab environment. And so now we can see here our NSX Edge is finished deploying here, and it actually hasn't even tried to do the power on yet, but let me see if it lets me edit settings. And we're going to go ahead and remove the reserve all guest memory. I'm going to change this to gigabytes and then change this to 16. And we're also going to change this to 16. And we'll go ahead and press, and it's actually not letting me press OK, and that's because this wizard that we have running in NSX over here, it would have normally tried to power it on, and when I first clicked edit settings, I hadn't seen that power out action. So it's a good idea when you're doing this, wait till you see this attempted power on that failed before you go to edit settings, or it may not let you edit the settings. So now let's go ahead and do that again. Edit settings. We'll go ahead and unreserve our guest memory, and we'll leave CPU alone, but we'll change this again to 16 gigs total used. Okay, and if you are on, as we loaded the baseline 0.5 template, you will need to lower the CPU count to 4. On the baseline 0.6 template, you can actually leave it to 8 because we've increased the CPU allocation. But on the baseline 0.5 version, you'll need to decrease that to 4 CPUs. And then we can click OK there. And once we've clicked OK, we should be able to right-click this. And you want to make sure that you have that completed status under Reconfigure Virtual Machine. And then we can right-click the NSX Edge VM and go ahead and power on. Now that's going to take several minutes to boot up and synchronize. You may want to go ahead in here and maybe press previous and next one time to refresh, keep your browser session from timing out. If it does time out, you can jump back into the same screen, just as we did when we started it, but that should hopefully keep it from timing out. I'm going to pause the video while this goes through the process. Okay, we're back now. My Edge is up and running, but my window did time out, and so I do need to log in again, and that is described here in step 3.7 of our lab guide. And so it does, you just sign back in, click on system, click get started, click set transport nodes, just like we did to get started here to begin with. And then we'll pick our Edge node, NSX Edge 1. And we can see our node is set to ready status here. We can go ahead and click next. And that I'm on, let's see, step 3.9 here in the lab guide. So we'll go ahead and click overlay transport zone. Call this overlay -TZ. And our NVDS name is going to be host switch -overlay. And we'll go ahead and add that. And now we can see our new transport zone is selected, and we can click next. let's see, where are we? Select uplink profile east-west, step 3.12. We're going to collect the select this NSX Edge single NIC uplink profile. This is available in here by default, so we don't have to create that. And then go ahead and click next. And here we're going to, on the link to transport zone east-west, we're on step 3.13. We're going to go ahead and click use IP pool, and we're going to select that TEP IP pool that we created earlier. And let's see. And then down here, we scroll down, we see our NSX Edge NIC connections, and we're going to just set the only value that we'll set here is only for FPETH1, and we'll set that up to the uplink 1 profile, and go ahead and click next. And now under this select transport zone north-south, we'll go ahead and create our VLAN transport zone, and we'll call this VLAN-TZ. And we'll call this host switch-VLAN right here. And click add. And then we'll click next. For our uplink profile, we'll go ahead and grab this NSX Edge single NIC uplink profile again. And on this next tab, let's see, link to transport zone north-south, that's step 3.19 in the lab guide. We're going to leave this as blank or empty, and that's because this is a VLAN. You don't see it in this particular wizard, but if you actually go to the setting this up through the other view, you'll see that when you assign this to a VLAN-based transport zone, that you don't actually typically assign an IP address here. And let's see, where are we? So link to transport zone no south. So we're going to set FPETH0 to uplink 1 on this. Leave everything else blank, and go ahead and click next. And on the add to NSX Edge cluster screen, we're going to go ahead and we're going to create a new edge cluster, and we'll call this edge cluster 1. And then click next. And now we'll add a transport node name here. We'll call this edge-tn-1. And go ahead and click finish. So I don't know if you saw, it looks like I clicked finish twice there, and the second time I clicked it, it came up with an error saying, hey, it's already deployed, and that's because the first time I clicked finish it was fine. So to verify that, you go to System, Fabric, and then Nodes. We'll go ahead and go to Edge Transport Nodes, and we can see here now we have this Edge TN1. We see its configuration state is success, its node status is up. We can see it's connected to the VLAN and the overlay TZs as we had configured it, right? And so our configuration applied successfully. And that Edge wizard allowed us not only to set up the Edge itself, but also to set up some of the transport zones and other assets that we needed to get up and running for our NSX environment. So the next step, if you're following along with the lab guide, is we're going to move into step 4, prepare and configure ESXi hosts as NSXT transport nodes. Right? And so this, so any ESXi node that will be participating in the NSXT logical networks needs to have the ESXi hosts prepped. We install VIBs into the ESXi kernel on those hosts, and so we'll look at that process now. And we're going to use this new wizard here, sorry, on the system get started tab again, same one we used to set up the edge, except this time we're going to choose host cluster to prepare our host clusters. Okay, and so we'll select host cluster and pick next. Okay, and then we're going to pick, and we have to do both our compute and our management domains. So first, let's go ahead and do our comp. And you'll see here that it says host cluster selected doesn't have the NSX components. You want to install it, and then it's going to go out here and install the VIBs. And at this point, I'm going to give it a couple minutes to let this complete before I proceed. I'm going to pause the video while we're waiting. Okay, and now we can see that we see NSX installed on each of the nodes that are in our compute cluster, and NSX Manager connectivity is up, so we can go ahead and click Next. And this time, notice when we go through the wizard, the first time we went and created our overlay transport zones, but once they're created, you can just select them. If you don't need to create anything new, it's a much quicker process. And we're going to go through the NSX default uplink host switch profile here. So that's just our default option. Click Next. And now we're on step 4.6, link to transport zone east-west. So on this one, we're going to, let's see, use our IP pool, and we're going to use our TEP IP pool again. And this is going to ensure that as these hosts get their VM kernel NIC for the tunnel endpoints, that it is pulling from a valid IP address for that range. Okay, and then we'll go down to our host NIC connections, and we're going to set this to uplink 1, and click Next. And then finally, we'll finish. So simple, pretty simple process there. And now we're going to run through the same process again for the management nodes, starting on where are we? Step 4.9. If you're following along the lab guide. So we'll do another host cluster next, and then we're going to select. This time we'll select the management cluster, and this you don't necessarily need in a PKS or a deployment. Of course, we're doing NSXT now, but ultimately we're designing this with PKS in mind in this case, and we do use a logical network on the management for the PKS management plane in our standard PKS design. And if you're not doing PKS, you don't necessarily need to enable your entire environment for NSXT. It needs to be just the nodes that are going to be have virtual machines that connect to NSXT logical networks. And so in some cases you may not need to configure your management network, but for our standard installation here we do. So we'll go ahead and install this, and I'm going to pause the video while that's okay. And we can see now that the all the ESXi hosts in our management cluster are configured. Click Next. You can select our overlay TZ transport zone and click Next. And we'll use again the default uplink host switch profile and click Next. And here we're going to go ahead and use IP pool and select that TEP IP pool. And keep in mind, even though before we set the same pool of IP addresses on our compute cluster, we're also using this for our management cluster. And again, this is for the purpose of creating that tunnel fabric between all the ESXi nodes that participate in those NSXT logical networks. And so all the nodes will participate in the same fabric and have the uplinks there, and so they can all communicate and pass all of our application traffic seamlessly across whichever clusters that we want to connect. We set our VM NIC to uplink 1, click Next, and then click Finish, and that's that. And then we can go into the nodes and go over here. Now notice there's nothing by default. That's because that managed by is standalone hosts. We'll want to change that managed by value, because NSXT does support standalone nodes, KVM nodes, etc. In our case, again, everything's connected to vCenter, so we'll change that to VCSA. And as soon as we do that, we can see our two clusters pop up here, and we can expand our cluster value. And if we do that here, we can see here that now the configuration is configured. The configuration state is success. The management cluster redeployed after the compute cluster, so it's still just converging around that node status. We can see as we go into the compute cluster, we see that's up across the board. So give it a refresh here. Okay. And now we can see that on the management and the compute cluster, our node status is now up. Everything's up across the board. And that actually completes the basic NSXT installation. We can see now we have all of our nodes prepared to be able to support any type of configuration, logical networks that you want to configure on top of NSX. They'll now be supported on all of your ESXi nodes. And the other component here, if we go into our edge transport node, is our edge. It plays an important role to be the gateway between the external networks and the internal networks. And so that's all set up and prepared and ready to start placing configurations. And that's the end of the base NSXT manual install. Next, we will look at the PKS configuration, or sorry, NSXT configuration for PKS.